The constant gate bias we looked at in the last video is pretty simple, but does have a disadvantage of requiring two separate power supplies, one for the gate and one for the drain source circuit. So can we devise a bias scheme which only requires a single voltage? The answer is yes, and this is called self-bias. To see how this works, look at the diagram on the screen. The gate is tied to ground by RG, as in the last video. This is just a large resistor, and there's no voltage across it because there's no current going into the gate. I gate is equal to 0. Now let's say a current is flowing through the drain source circuit. In fact, let's say that it's 5 milliamps as in our last video. Then this will cause a voltage to appear across RS. If we say that RS is 400 ohms, for example, then we'd have a situation which is now shown on the screen. But if we think for a moment what this means, the gate is at 0 volts and the source is at 2 volts. So the gate is minus 2 volts below the source. It's at minus 2 volts compared to the source. Exactly what we had in the last video. So the addition of RS has caused the FET to bias itself. Graphically, we can choose this resistor RS from a characteristic as shown on the screen. We can then complete the rest of the circuit as shown in the diagram now on the screen, RD being chosen in the same way as in the previous video. This time, only a single power supply is required for the whole circuit.